Hi, in this video we will be discussing on divisibility tests. A whole number is said to be divisible by another number if after dividing the remainder left is 0. So we say 8 is divisible by 2 because after dividing 8 by 2 we get a remainder of 0. So in general if a whole number b is divisible by a, then we say b is a multiple of a and a is a factor of b. So in this case 8 is a multiple of 2 and 2 is a factor of 8. And a divisibility test is a rule for determining whether a given whole number is a factor of another number. And we have various divisibility tests for various numbers. There are a few conventional ones and few unconventional too. I'll try to discuss what we need for aptitude examinations. Let's start with the number 1. Every whole number is divisible by 1. So there's nothing like a divisibility test for 1. And a number is said to be divisible by 2 if the units digit is divisible by 2. So let's say we have a number 2, 3, 4, 5, 3, 2. Just take the last digit 2. If this is divisible by 2, the number is said to be divisible by 2. So then a number is said to be divisible by 2 if the units digit of the number is either 0, 2, 4, 6 or 8. And a number is said to be divisible by 3 if the sum of all the digits of the number is divisible by 3. So let's take a number 372. Add 3 digits, we get 12, which is divisible by 3. So the number itself is divisible by 3. A number is said to be divisible by 4 if the number found by taking the last 2 digits of a number is divisible by 4. So let's take the same number as we took for 2. The number is 2, 3, 4, 5, 3, 2. Take the last 2 digits. So consider the number formed by taking the last 2 digits, 32. 32 is divisible by 4. So the whole number is also divisible by 4. A number is divisible by 5 if the units digit of the number is either 0 or 5. So 75 is divisible by 5 and 2, 3, 4, 5, 0 is divisible by 5. Okay. A number is said to be divisible by 6 if it is divisible by both 2 and 3. Obviously, because 2 has factors 2 and 3. And divisibility test for 7. We don't have a conventional divisibility test for 7. It's not a standard one, but people came up with an unconventional way of checking. So just remember, when you need to check if a number is divisible by 7, remember the series 1, minus 2, minus 3, minus 1, 2, 3. So this is a sequence which you have to remember to check if a number is divisible by 7. So how is it going to happen? Let's take a number 217. We need to check if this number is divisible by 7. So what we do is, whatever is a given number, consider the number digit by digit from left to right. So we have 2, 1, 7. These are the digits. And multiply each of the digits with the corresponding number in the given sequence. If there are more than 6 digits in the number, the sequence continues. So 1, minus 2, minus 3, minus 1, 2, 3, 1, minus 2, minus 3, minus 1, 2, 3. So the series goes on. So you multiply 1 and 2, 2, plus minus 2 and minus 1, minus 2, plus minus 3 and 7, minus 21. So this will be minus 21. And if the resulting number is divisible by 7, the given number is divisible by 7. So 21, yes, it's a multiple of 7. So the action number 217 is also a multiple of 7. A number is said to be divisible by 8 if the number found by taking the last 3 digits of the number is divisible by 8. So let's take the same number 2, 3, 4, 5, 3, 2. So we take the last 3 digits here. So we get 532, and we can easily see that 532 is not divisible by 8. So the whole number is not divisible by 8. And moving further, a number is said to be divisible by 9 if the sum of all the digits of the number is divisible by 9. So it's same as for 3. So we have the same number 372, add all the digits, we get 12. 12 is not divisible by 9, so this number is not divisible by 9. A number is said to be divisible by 10 if the units digit of the number is 0. It's quite obvious. And a number is said to be divisible by 11 if the difference between the sums of digits in the odd places and even places is a multiple of 11. So let's take an example. 121. So what you do is you sum up all the digits which are in even places. So there is only one thing, the second place. So this is the number. You also sum up all the numbers in the odd places, the first place and third place. That's 1 plus 1 is 2. So you have sum of all the even placed numbers, digits, and you also have all the odd placed digits. And you take the difference of these two. And if the result is a multiple of 11, then the actual number is a multiple of 11. So 0, yes, it's a multiple of 11, 11 into 0. So this is a multiple of 11. And a number is said to be divisible by 12 if it's divisible by both 3 and 4. Quite simple. Just factorize 12, 3 and 4. We have divisibility test for both 3 and 4. And a number is said to be divisible by 13 using a unconventional divisibility test, same as what we use for 7. It's exactly the same, but the sequence for 13 is different. The sequence is 1, 4, 3, minus 1, minus 4, minus 3. So take the sequence, apply the same rules. That's the divisibility test for 13. And a number is said to be divisible by 14 if it's divisible by both 2 and 7. Quite simple. And a number is said to be divisible by 15 if it's divisible by both 3 and 5. A number is divisible by 16 if the number found by the last 4 digits of the number is divisible by 16. So now we can actually generalize certain things for 2 power n and 3 power n. A number is said to be divisible by 2 power n if the number found by taking the last n digits of the number is a multiple of 2 power n. Very simple. And a number is a multiple of 3 power n if the number found by summing all the digits of the number is a multiple of 3 power n. So 3, 9, 27, all these numbers have this. And one more thing to note, let's say we have a number, say 21. So to have divisibility test for complex numbers like this, we factorize this 3 into 7. So a number is said to be a multiple of 21 if it's multiple of 3 and also multiple of 7. So what you do is, given a product of two numbers, the number is product of that. If a number is said to be a multiple of AB, if it's a multiple of A and also a multiple of B, provided that A and B are relatively prime. We'll see what relatively prime is in the next video. This concludes the video on divisibility test. See you in the next video. Bye bye.